Hello, my name is Warren Sims, and today I'll be interviewing Dr. Wilhelm Conrad Roentgen, the discoverer of X-rays. Now, Doctor, please introduce yourself to the nice people and tell us a little bit about your project. Hello there, and as Warren said, my name is Wilhelm Conrad Roentgen, and I was a professor at Würzburg University in Germany, and I'm contributed with the discovery of X-rays. It was November 8th, 1895, and I was working with a cathode ray tube in my laboratory, and I observed something strange, a fluorescent glow of some crystals on the table near the tube. The tube that I was working with, commonly referred to as a Crookes tube or a cathode ray tube, consists of a glass bulb with positive and negative electrodes encapsulated in it. The air in the tube is evacuated, and when high voltage is applied, the tube produces a fluorescent glow. I then attempted to shield the tube with some heavy black paper and discovered a green-colored fluorescent light generated by a material located a few feet away from the tube. I concluded that a new type of ray was being emitted from the tube. The ray was capable of passing through the heavy paper covering and exciting the phosphorescent materials in the room. After some more experimentation, I found that the new ray could pass through most substances, casting shadows of solid objects. I also discovered that the ray could pass through the human tissue, but not bones and metal objects. One of my first experiments, late in 1895, was a film of my wife Bertha's hand. A fun fact, the first use of X-rays were actually for an industrial application, not medical as most of you might imagine. I produced a radiograph of a set of weights in a box to show off to some of my colleagues. Soon public fancy was caught up by my recently discovered invisible ray, since it had the ability to pass through solid matter and in conjunction with a photographic plate could provide a picture of bones and other interior body parts. Scientists were also quite captured due to the demonstration of a wavelength shorter than light and its many possibilities. Dr. Roentgen, what were you guys trying to do or find? Well, Warren, my experiments at Würzburg focused primarily on light phenomena and other emissions generated by discharging electrical current in Crookes tubes, just like the one I described earlier. Glass bulbs with positive and negative electrodes evacuated of air, which display a fluorescent glow when a high voltage current is passed through it. I was particularly interested in cathode rays and in assessing the range outside of charged tubes, so that's exactly what I was doing on that day. And doctor, where did this experiment occur? My laboratory at Würzburg University in Germany. And doctor, what were some other significant events that were going on around the world at this time? Well, in America, Jane Addams, known for her Hull House, was appointed as garbage inspector for her city of Chicago after much discourse. Winston Churchill, the future British Prime Minister, traveled to Cuba to observe the fighting between Spanish and Cuban forces. Babe Ruth, the Sultan of Swat, and future New York Yankee baseball player and icon, was born February 6th of 1895. Frederick Douglass, the great abolitionist, died February 20th, 1895. Booker T. Washington, the great African-American spokesman and leader, delivered his Atlanta Compromise speech September 18th, 1895, and the first American automobile race was held at 8:55 a.m. on November 28, 1895, where 6 motorcycles, not to be confused with the later invention of the motorcycle, left Chicago's Jackson Park for a 54-mile race to Evanston, Illinois, and back through the snow. Number 5, piloted by inventor J. Frank Durow, won the race in just over 10 hours at an average rate of speed of 7.3 miles per hour. The winner earned $2,000. The enthusiasts who named the horseless vehicles motorcycles won $500. Who else was involved in this project of yours? I'm credited with the discovery, but I was by no means the first person to notice how certain rays made other materials fluoresce. In fact, the cathode ray tubes that I used that day had been developed, and I'd borrowed them from a fellow physicist, Philip Lenard. Additionally, a full 5 years earlier, Arthur Goodspeed, an American physicist, had left 2 coins on some photographic plates near a Crookes tube, then noticed that the developed plate showed 2 mysterious circles. The difference in my work and his is that I followed up my discovery by choosing to investigate the ray's origins and effects. What was your role in this project? Honestly, I just happened upon it. I didn't think, I investigated. What impact did your project have on the physics community? It generated a wide variety of new possibilities in the physics field and for investigating the structure of matter. Later on, J.J. Thomson showed that X-rays were able to ionize gas, and the study of this phenomenon led to the discovery of electrons in 1897. In March of 1896, in order to understand the emission of X-rays, H. Becquerel investigated the role of phosphorescence of glass of the tube, and while doing so, discovered radioactivity. Further research of radioactive materials demonstrated the existence of atoms, which until then had only been a convenient hypothesis for explaining chemical reactions. Moreover, interaction of particles emitted by radionuclides and atoms enabled first the study of the structure of the atom and subsequently its nucleus. Matter, elements which are thought to be immutable, were found to be transmutable and eventually to disintegrate. The origin of the energy transferred to the radiation which was emitted appeared as a mystery. In order to explain it, physicists had to accept that matter could convert energy, and in 1903, Einstein established the equivalence between matter and energy. Matter, energy, electricity, light, which were formerly considered as continuous quantities, were found to be discrete. There are particles of matter, elementary particles, energy, quanta, Planck, which came up in 1905, electricity, electron, light, photons, radioactive decay, particle interactions imposed in probabilistic physics, which progressively replaced classic determinism physics. It was determined that the radioactivity could be used as a clock to measure time in the universe. Datations were made for fossils, art masterpieces, and also for the Earth, solar system, and universe. X-ray diffraction proved to be a powerful tool for studying crystals and molecules in the particular protein, and in 1953 enabled to demonstrate the DNA double helix. Hence, X-rays and radioactivity originated a revolution in physics and science and in the vision of nature. The imperceptible and yet so powerful rays demonstrated the deficiencies of our senses. Now finally, Doctor, how is your discovery being used today? Although I'm no longer around, I can really appreciate how far my discovery has come. In today's world, doctors order X-rays to diagnose all sorts of problems such as broken bones, pneumonia, heart failure, and much, much more. Mammography, the standard screening method for breast cancer, utilizes X-rays. You all barely think about it. It's become so ubiquitous. But not so long ago, broken bones, tumors, and foreign objects could not be found without very invasive operations. Thank you very much, Dr. Roentgen. Why, the pleasure was all mine. Thank you all for watching my interview. I appreciate you taking the time to do so. Hope you all enjoyed it and learned a little bit about Dr. Roentgen and his discovery of X-rays.